this midterm quite good. Yeah. So I graded currently 12 students. Yeah. There are 2 students, 1 student, 15 are in our list, roll call list. The 1 student actually dropped it. As I remember, I approved. So once one of the 15 already dropped it, but his name still in our list. Yeah. So actually we have 14 students. 14 students, but there is 1 in this 14 students never respond. You know. Yeah. No activity actually. 1 of the 14 students, you know, never does anything. That student. Yeah. So that's, other than that, we have 13 students. Okay, 13 students. This midterm I graded 12 students, and the overall overall average is greater than 80%. 80%. Yeah. So that is very good. Yeah. So this midterm actually pretty good. Yeah. So if you can keep doing like the midterm, so then I believe you can also do well in the final. Okay, the final, because I will give you all 10 question types explicitly with sample questions. So when you prepare, so right now you have 1 week for the preparation, because our final is May 6th, Tuesday, 1 week from today. Yeah. So that's your preparation time. So you focus on those 10 question types. Okay. Today you get 5. Thursday you get the remaining 5. So total, after Thursday you have all 10 question types. You just focus on these 10 question types. You know, get familiar with, you know, how to calculate all those things. So then I believe your final should be pretty good. Yeah. Based on the midterm. Okay. Yeah. So that's based on this midterm. Oh yeah. All right. Yeah. Now let me make comments for each question. I make some comments. Some question relatively easier, so I can move much faster. Some questions I need to explain a little more. Yeah. All right. Yeah. Oh. Yeah. I need to plug in my remote control. Yeah. All right. Okay. It works. Yeah. The first question, very easy. So most students did it quite well, but one small problem. Yeah. For some students, when they get that integrating factor, they write this x cubed integrating factor directly. Yeah. So because I need to know how to find it. I need that. Okay, because you cannot guess it, right? Although you can guess, but the chance to find the right integrating factor is small. So I need to know how to get it. Okay, yeah. So several students didn't give me the details how to get it. So here we do the calculation to tell us how to get it. Okay, so that is the first question. Only this problem. Yeah. The second question, you need to do the substitution. Yeah. So if you do this way, then it is very easy. But one student didn't know using this method. Okay, only one of the students, try very hard, but couldn't get it. Very hard. But all the other students, so they know using this method. Then the last thing, actually for the answer, if you get this implicit answer, it is already okay, implicit. But most of you converted to explicit. So most of you converted to explicit. Actually, it's not wrong. For this question, it's not wrong. Because this question, when you convert it to explicit, you need to use the inverse tangent or arctangent. You need to use this function. The good thing is the range of this function is the whole real numbers. For that reason, so your expression is good. But I don't know. So if you know that, because we did similar question before, if we have question related to the inverse sine or cosine, then if you do this way, then you may have problem. Okay, so that's why this implicit way is safer. Safer. Because when you have sine cosine implicit equation, if you want to convert to this one, then because the domain you only cover from -1 to 1. Think about if the number inside the parenthesis is out of this range, then you have trouble. Okay, but in explicit equation, you do not have that problem. In the explicit representation, because you do not use this inverse function, so okay. So this inverse version, because actually when you take this one, there is more consideration. Due to this, this range, due to that range. But here we skip that consideration. Okay, because sometimes people need to plus 2 pi k, 2k pi. Okay, so that's the extra consideration. Because you cannot, you cover the whole real axis by adding this 2 pi k. But here you skip that part. So for that reason, it is not safe, right? This way not safe. So my comment is keep the implicit form. Okay, keep the implicit form. Then it is safer. Okay, it is safer. So that's this question, number 2. Number 3, most of you did well. Because you solve, then many students find a k. Because you can find a k number from this. Many students, not here. So let me see. Anyway, because you need to do some cancellation thing, right? You can find, because so you can do some cancellation. So you try to cancel the t0, then you can find k. But here I do not find a k. So here I try to, because when you do intermediate calculation, you may lose some precision digits. I saw some students use many precision digits when they calculate k. That's okay. So that make sure the final answer, still keeps a lot of precision digits. Yeah, that's okay. Yeah. So here I just find the formula, T0 formula, getting around that K value. Yeah. So then, same answer. Yeah. So this one probably the best one. When I look at the, all of you. Yeah. Question number 4. There is one point. So many students didn't get it. A small number of students got it. Yeah. As I remember, 3 students got it right. Yeah. Other than those 3 students, most students miss this point because we are given, from Y1, Y2, because we are given the information for 2 time points. Yeah. So from those 2 time points, you can estimate the Y0 with 2 different values. Yeah. Yeah. So here, this question, when I made this question, I didn't realize that. Yeah. Two different possible values, but it is okay. It happens in the real world. In the real world, we need to estimate some number, right? Yeah. So when we estimate some number in the real world, we may have several estimates, right? Yeah, because based on the information given, we may have several estimates. In that case, here we have 2 estimates, these 2. So how to get the best estimate you can have? Yeah, because we do not know, is the first one better or second one better? Okay? Yeah. Then the most reasonable way, we take the average. Yeah. Yeah. So this is the, we can treat as a fair way, right? So we can treat it as a fair way. Yeah. 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 So the best way, you take average of these 2 estimates. Yeah. Yeah. Some students didn't do this step, so I took 1 point off. Okay, 1 point. Yeah. Yeah. So when you have this kind of situation, because in the real world, you will have situation like this a lot. So when you need to produce the final answer, you need to find the most reasonable one, okay, based on the information you get. So you need to provide the one that is closest to the number you want to find. Yeah. So that's this question. All right. That question number 5. Yeah. Question number 5. Most of you did all right, but there is a common problem. Yeah. There is a common problem. So when you solve, when you do integration, so many of you give that, constant C, right? Yeah. But when you, at the end, when you do operations related to constant C, so then most of you miss that. So the final answer, other than this part, yeah, plus another C. Yeah. So most of you missed this term. Yeah. Here I use, I write that C more explicitly. Yeah. Yeah. Because I0 we know, so that's the current value, initial current value. Yeah. Yeah. More explicit. But for you, if you keep this C, it's okay. Yeah, yeah. But still, most of you missed this term. Yeah. So that's the main question of this one. Yeah. Then number 6. Number 6, the biggest problem here is most of you didn't use this choice rules. Okay, so most of you use that variation of parameters, that method. Variation of parameter. Yeah. Of this method. Yeah. It's okay. So you still, they got the correct answer. Okay, so they got the correct answer, those students. But because in the requirement, I ask you to use the choice rules. Yeah. So the only thing not perfect because you didn't use the choice rules. Okay, so for that reason, I took 1 point off. Okay, yeah, I just took 1 point off. Let you know, you didn't use the choice rules. Yeah, yeah, and I remember before the deadline, I post a video, hint video. So I give you one example, explain how to use the choice rules. Yeah, yeah, but most students still, I think, fail hard. Yeah, so they fail hard. They didn't know how to use the choice rules. Yeah, so I saw one student trying to use choice rules, but did it the wrong way. Yeah, one student I saw, trying to, when they take the YP form, because you need to write YP form, you should do this way. Yeah, but that student didn't use, multiply that x squared. So didn't use the right way. Yeah. Yeah. So that's the main problem. Okay. So following the requirements first. Yeah. But yeah. So here I want to talk about the final exam, because final exam we will have the similar situation. Okay. Yeah. So in the final exam, because some questions I will ask you to use certain specific methods. Yeah. Yeah. In that case, if you can use that method to solve, then you need to try to use it. Yeah. But there is a situation. Yeah. Because if you use that method, you do not know how to solve. So that's the main problem. Okay. Yeah. In that way, so you need to accept the second best thing. Yeah. You need to choose the second best way. So that means whatever way you can solve it, just solve it. Yeah. But in that case, I just take 1 point off. Okay. Yeah. If you do not use the required method, yeah, I will not take too many points, just 1 point off. Okay. In the final. Finally, you will have similar situations. Yeah. Yeah. Later, when I give you sample questions, I will talk about one sample questions. Yeah. Related to this requirement thing. Yeah. All right. Number 7. Yeah. The most important thing, number 7, is decomposition of the fractions. Yeah. How to do decomposition? Yeah. I notice most students, they use the partial fraction, the standard method for the partial fraction decomposition. Okay, so use A, B, C, D. Some partial fraction forms. Then plug in all or compare the coefficients, then set up, you know, 4 equations solving for these numbers. So although it's correct, but usually it's very time consuming, right? Yeah. So I can see, so they did a lot of calculation, you know, sometimes very messy, yeah. And some of the students just, you know, give up, okay? After some steps, they gave up. So they couldn't complete it, yeah. So especially at the inverse Laplace transform step, yeah. After they find A, B, C, D, you know, too exhausting. So they just, you know, dropped the remaining part, yeah. Several students did that way, yeah. In class, I showed you one special way, you know, so we do not use the partial fraction way. We have some splitting way. Yeah, we can split fraction with some special techniques. Yeah, but based on my grading, most of you couldn't get it. Yeah, because you need to have some experience. You need to have some, you know, good observation experience. So then you can do it in that way. And later, after this comments, I will use the examples here. Examples in this midterm, I will show you how to split the fractions. Yeah. So in my solutions, I did that, but I will use my PowerPoint slides to explain how to split. Yeah. So if you can understand, yeah. So later, so then you don't need to use partial fractions. You just, you know, do the split directly. Yeah. Yeah. If not, then partial fractions, because it's very time consuming. Okay. So too much work. Yeah. All right. Yeah. So this operation, so I skip because later I will use PowerPoint slides to explain the details. Yeah. All right. Number 8, the same thing. Yeah. So at a, you know, split. Yeah. All right. So then the last question, number 9, also the same thing. So now last question, here I give 2 solutions. One solution, we get the equation, we solve the equation for this Q function. Yeah. The Q function, all right? Yeah, by Laplace transform. But after that, we need to take a derivative, okay? After you get a Q function, then, because our goal, we need to find I function. So you need to take a derivative to get I function. Yeah. Yeah, some students forgot to take derivative to get I function. Yeah. But the solution 2, we solve the equation for I function directly. Then you do not need to take derivative. So because you will get a I function directly. Yeah. So you keep this integral form. Okay? Yeah. But when you do Laplace transform, so the integral, we have this formula. Okay? Yeah? So the Laplace transform, this capital I, you divide it by this S. You get a Laplace transform of this integral form. Yeah. So that is very convenient. Yeah. After that, so then you solve Laplace, you just, you know, do the fraction decomposition, inverse Laplace transform. So yeah, still a lot of calculation, but you will get the I formula directly. Okay? Yeah, actually the calculation, the fraction calculation part, a little harder than the Q way. Yeah, Q way, the fractional part a little easier. Yeah. so these two methods pretty much similar difficulty. So I will say similar difficulty, yeah, because for the fractional calculation, this part relatively easier, yeah, but you need to do one more derivative, so a little more work, yeah, calculation. So this, the second one, you avoid that derivative step, yeah, but when you do the fraction calculation, you need to do a little more work, yeah. Okay, yeah. So you can see a little longer, yeah. But you should get the same answer, yeah. So I compared, I verified, same answer, yeah, yeah. After when I made the answer the first time, I didn't get the same answer. So actually, one of the two solutions, the calculation is wrong, yeah. So then I double check it. So I found my Q solution, yeah, something was wrong. Yeah, I solution is correct. Q solution was wrong. Yeah, then I correct it. Yeah. All right. So that's the midterm, the comments. Yeah. Yeah. But the overall, I think you did quite well. Yeah, because above 80%. Yeah, the average above 80%. Yeah, yeah.
I have one question.
Yes.
On number 7.
Number 7.
Yes.
Number 7. Oh, yeah, right here. Okay.
So wait a minute. Sorry. Number 9.
Number 9. Okay. Here. Yeah.
So in your final answer, I see that one more time.
Yeah. Final answer here. Yeah. Yeah.
So I had, for example, one of my terms was 2 cosine t minus 2 pi times
Oh.
any some function u t minus 2 pi. And you said we could simplify.
Right. Good. Yeah. Yeah. Many students like that. Let me explain that. Yeah. Several students like you. So your second part. Yeah. One part. So you have you include t minus 2 pi and cosine t minus 2 pi terms. Okay? Yeah. So then I said it could be further simplified because this is equal sine t. This equals cosine t. Because remember 2 pi periodic, right? The difference is 2 pi. Why you just remove that 2 pi?
The value is the same.
Right, very same. So in that situation, you should take the simplest way. All right? Although it's not a big problem. The answer is correct. Yeah, but we want to have the simplest form. Yeah. Yeah. The important thing is, yeah, think about this. Yeah. So that's why, yeah, it's good. So you remind me because it's not just like you. As I remember, 3 or 4 students had the same problem. Yeah. So I took 1 point off for this reason. The reason is, think about, because I want you to really avoid things like this. Think about when you work in the real world situation, yeah, when you provide a solution to your customers or to other people, if you write this one, then if some expert see your solution, they will make very bad comments. Okay, yeah. So that won't look good. Yeah, that won't look good. Yeah. So you should not give your solution containing things like this. Okay. So this kind of low-level errors. Yeah. Yeah. So some cheap errors, things like that. Okay. So I would like to. So you really need to avoid things like this. If you get some high-level errors, then people can understand. Yeah, because it is hard. Yeah, but things like this, because so easy. Yeah, so you definitely you need to try your best to avoid errors like this. not really the error, just not perfect. Okay? Things like this. Yeah. Yeah. So that's why I took 1 point off. So I want you to get a good impression. Okay? Yeah. Do not make the similar problems in the future. Yeah. Yeah. 2-pi periodic. For some students, I wrote that. Use the 2-pi periodic property. Try to remind you. Okay? Yeah. Because not just the reason I think you couldn't connect it to the 2-pi periodic, because you are used to, if you see t plus 2-pi, you can do simplification, right? Plus, right? So our 2-pi. But here it's minus. There.
Same thing.
Yeah, same thing. Yeah. Same thing, plus, minus. But you are not used to it, right? Yeah. 2 plus 2-pi, you feel easier, but minus, you couldn't connect it. Yeah. So, some psychology thing. Yeah. All right. Yeah. Then let me look at the time I left. Okay. I still have 10 something minutes time. Let us do once. Oh, yeah. Because next I need to do the fraction split topic. Yeah. I want to show you some fraction split technique. Because in our final exam, you will have 2 Laplace transform questions. Yeah. One using the differentiation formula. Another use the integration formula. So you need to do some, fraction decomposition work. Yeah. So I think many of you still use that partial fraction way. But here, if you can use my way, so I will explain the direct split way. Yeah. So we do not use A, B, C, D. Yeah. But it's not easy to master the technique. Yeah. Yeah. Let me see. I try to use the 10 minutes to show you the first example. I took several examples. So let me show you the first example before the break time. Yeah. I need to get to my PowerPoint slides. Yeah. All right, let me save this file first. All right. Yeah, so how to split fractions. All right. All right. Yeah. All right. So let's see. Yeah. Yeah. The first split. This example. Yeah. Before I work on this example, so I want to talk about a general case. Yeah. A general case. Yeah. Yeah. Because most of them, my split are based on this general case. So what's that general case? All right, so when we have a fraction like this, s minus a, s minus b. This is the general case. Yeah. And when we write the fraction in this form, we want to make a less than b. Okay? We want to order these two factors in this order. Okay? A less than b. Yeah. Yeah. Because in this way, we can, inside parentheses, we can use 1 over s minus a minus 1 over s minus b. Okay? Then outside we need to do some coefficient adjustment, b minus a. Yeah, outside. Because when you do the common denominator, then you do subtraction, you will see the numerator becomes b minus a, right? Yeah. The numerator b minus a, then you need to multiply 1 over b minus a to cancel out the numerator. Yeah. So make the numerator equal to 1. Yeah. That is the basic formula. Yeah. Okay? So if you keep this in your mind and do practice, yeah, then a lot of fractions you can split, easily. Yeah. Yeah. But that's not enough. After this example, later we have example with square terms. That square term, we need to use another technique. Okay? All right. But this is the basic one, the easiest one. All right. Use that formula. Let me show you how to split this one. This time we have the denominator. We have 3 factors. Yeah. But the 3 factors we do split multiple times. Every time we just split 2-factor. 2-factor case. All right. So this one, when we write, you need to take 1 factor out to do split. Okay. So here I take this s plus 2 factor out. Yeah. 2 factor out. If you ask me why I take s plus 2 factor out, because I think this is the easiest way, although you can do a different way. Okay, later I will show you a different way. Yeah, here the why easiest way, this s times s minus 1, is it, yeah, is it in the same as that form, right? Yeah, and difference between actually 1 minus, difference between these two, a minus 2. Sorry, probably b minus, a greater than b, right? Because minus. So, yeah, because minus a less than minus b, actually a greater than b, okay? Anyway, so you can figure out, okay, the order. So here, because this is 0, that one, 0. Yeah. Probably. Yeah, probably it's okay. So a minus b. Yeah, a minus b. Because s minus 0, right? B is 1. Yeah. So a less than 1. Okay. Yeah, I got confused. Because difference is 1, then your denominator is 1. That's the easiest case. So that's why I like to take out s plus 2 first. Then inside, we can use that split directly. Okay? S plus 2 times 1 over s minus 1 over s minus 1. Sorry. Yeah, sorry. Yeah. Should be different. Yeah, should be different. Then yeah. Then the order. Yeah, order. Yeah. Anyway, sorry. Yeah. Actually, yeah. Whatever. Yeah. So actually, yeah. Greater than b. Yeah. All right. Yeah. So in this way, you have s minus 1 times s plus 2 minus s times s plus 2. Yeah, actually, another way, if you use plus, then it's better. Here we use minus. Yeah, so probably another version we use plus. Okay, s plus a times s plus b equals, this time we make a less than b. Okay? Yeah, because plus it's easier. The minus, we need to change the direction. Then s plus a, the smaller one, minus, I need to do multiplication. I need to use b minus a. S plus a minus s plus b. Yeah, in this way, Yeah, it's easier than that. Okay, because that one, which one minus which one, okay, you need to compare. This one we use the natural order. Okay, all right. Then, based on that, we need to apply split another time. Okay, another time apply this formula. Yeah, let's use this formula. Okay, all right. So let me look at the time I have. Oh, 2 minutes. Yeah. Anyway, 2 minutes. Let's apply another split. Okay. The first one based on our formula, because the difference of these two numbers 3, right? So 3 times s minus 1 minus 3 times s plus 2. Yeah. Keep that order, okay? The second one, the difference is 2, right? So 2s minus 2s plus 2. Okay? Then you simplify it. Yeah. So then you write it. So that tells you if you use this basic formula. Yeah. So let me cross out that version. Okay. Yeah. So this is version better. We can control the direction better. Yeah. So if you, in your mind, so you get familiar with this formula, then when you do the work, so you apply this formula, split every time one split, you use this way, you can get around that ABCD, ABCD calculation. Okay, yeah. So and if you use this formula well, you can save a lot of time in our final, because in our final, time is another important factor. Okay, yeah. So you don't want to waste too much time. Yeah. All right, let's take a 10-minute break. Yeah. So after the break, so let me show you the remaining examples about the fraction